This mini series by doing some statistics, and this calculator is good for doing statistics. We have some data. It's levels of mercury in a polar bear hair from Greenland, and it's given in parts per million. So each value is a different polar bear. 6.9, 9.2, 7.2, 8.9, 3.4, 3.7, 8, 6.7, 5.8. This is, by the way, on page 230 in the book. 4.3, 6.8, 6.6, 6.0, 7.7, and 5.4. So we are asked to find the range, the upper quartile, the lower quartile, the interquartile range, and the median. We'll start on this, and then we're going to do some other statistics too. First of all, I have to enter my data using stat and then edit. That's the first step to doing any statistical analysis. I can do, now I have to just enter my data, 6.2, 9.2, to be careful when you're entering your data so you do it correctly, 8.9, 3.4, 3.7, 8.0, 6.7, 5.8, 4.3, 6.8, 6.6, 6.0, 7.7, and 5.4. Oops. Now there's two ways of actually finding these values. One is doing stat calc and one variable statistics. Let's write that up. So method 1 is doing stat calc and then 1 var stats and then enter. Probably the easiest way. And let's see, we're given some values here. If we go down, we're told that n equals 15, that's the number of data points. This stuff here we're going to ignore just for now. We're told that our minimum value is 3.4 and the maximum is 9.2, so our range is simply the max minus the min. So 5.8 parts per million, don't forget your units. The upper quartile here is given by the value which is called Q3, that is 7.7. The lower quartile is given by the value called Q1, which is 5.4. And in between Q3 and Q1 is 50% of the data, and below Q1 is the lowest 25% of the data, and above Q3 is the top 25% of the data. And the interquartile range is simply the upper quartile minus the lower quartile, 7.7 minus 5.4, 2.3. And the median here is given by the value in the screen called med, 6.6 ppm. which is, remember the median is if you line up all the values in number order, it's the one that would be exactly in the middle. The other way of doing that would be to displaying this as a box and whisker plot. If you remember how to do that, let's just recap. And you can do graphical plots by doing, or statistical plots by doing second and then stat plot. So method 2 is doing second and then stat plot, which is above your y equals button. Now we haven't got any plots turned on here, so I have to turn on plot 1 by pressing enter and then enter again. I have to go down to the type and scroll until I get the box and whisker plot type here, and then press enter, and then you graph it by pressing graph. If the graph is not in your window, you can zoom to the statistical plot by using the zoom function, zoom, and then go down to, let's see what option it is, option 9, which is zoom stat, enter. Now we have it in our window. I can use the trace button, and I have a little tracer here. That line there tells me the median, 6.6, just by reading off the screen. If I jump to the left, I jump to the lower quartile, which is 5.4. That's in agreement with this value here. If I jump to the left again, I get the minimum value. And then go to the right of the median, I have the upper quartile, which is 7.7. And jumping to the right again, I have the max, which is 9.2. I'm just going to quickly do an example of how we do a regression using the calculator, because it's also some statistics that you might be expected to do. As part of this last and final calculator tutorial, I'm going over this quickly, but you can always watch this again if you're unsure. Let's find some data. So we have a table of data, X, which in this case is days. This is to do with the heights of plants after planting them. So X days after planting them, the height Y centimeters is measured. And after 4 days they were 14 centimeters tall. After 6 days they were 22 centimeters tall. After 10 days they were 26 centimeters tall, and after 12 days they were 32 centimeters tall. And we want to find use a linear regression to find the line of best fit. Again, I enter my data using stat and edit. To clear the data quickly, you go to the top, to the heading, and you press clear and enter. L1 is going to be my X values, so 4, 6, 10, and 12. And L2 is going to be my Y values. Don't forget that the coordinates have to match up. So 4, the height after 4 days was 14, the height after 6 days was 22, the height after 10 days was 26, and the height after 12 days was 32. If you have more values than the X than the Y, or more Y values than the X, then it won't work. So you have to make sure you have the same number of pairs of data. Then I want to go and plot that data using second stat plot. I've already got my plot 1 on, so I just go enter, but this time I have to change the type to a scatter plot. Go hover on the scatter plot and then enter, and then go down. You should have that the X list should be L1 and that the Y list should be L2 as standard. If you need to change that, then you have to press second and the number to get, for example, L3. I'll keep mine on an L1 and L2, and then I go to graph, and I don't see anything. so I have to go zoom and then option 9 to fit them in the window. So I'll just write that down here, zoom, option 9, stat plot is good. Now, in order to do a linear regression, the final step, you have to go stat and then calc, not the normal calc. You have to do stat calc, stat, and then calc menu, and then you go down to option 4, linear regression, lin reg, and you get out a function in the form ax plus b. So your a will be your, in terms of a linear function, a will be your gradient and b will be your y-intercept. So you go to 4 and then enter, and if you have your values, your x values in L1 and your y values in L2, then you can simply just press enter here and it'll do the regression for you. And I get out y equals 2x plus 7.5, which means that every day on average the plants grew 2 centimeters and that they were 7.5 centimeters at day 0. If you want to find out how good the regression was, if you want the regression coefficient, you have to first turn on what's called diagnostics. So you go to second 0 to get the catalogue. You need to go down here, scroll to where it says diagnostics on, enter and enter until it says done, and then just repeat the linear regression and you get a R value, and this R value of 0.96 tells me it's a very strong correlation. That's it. Bye bye. See you.